Good evening, one and all. In today's session, we will continue where we had stopped last time. We had stopped with the closing note of that when there is a base class and a derived class, and we are using the concept of inheritance, then when we create an object of the derived class, that time the constructors of derived class and base class both get called. But in which order is that is important. When you create an object of derived class, then first the constructor of its base class, that is its parent class, that will get called, and then the constructors of its derived class, that is its own class. Okay, means for example, you have a parent constructor and you have a child constructor. Then whenever you create an object of the child, first of all, the parent constructor gets called, and next the child constructor will get called whenever you create the object of the child. But when you create an object of the parent, which all constructors will get called? Can anyone tell me?
Only parent.
Exactly. Only parent. Okay. Now let us get straight to the programs. So constructors and inheritance. So you have a base class called base one. You have a derived class called derived one. And you have another class called as child of derived. So three classes in total. And how it is inheriting is you have a base class. From that you have a derived class called derived one, and from the derived one class you have child of derived. So there are three classes. Okay, so if you want to see the diagram, then it is something like this. Base one class you have, from that you have the derived one class, and from the derived one class you have child of derived class. Okay, so which type of inheritance is this? Can you tell me if you remember? It's like a chain of
Multi-level.
inheritance. Yes, exactly. Okay, multi-level. I think Pratik Gupta is only answering. I think so. Am I right?
No.
Then who is it answering?
Me.
Okay, okay, it's you. Okay, okay. The voice was similar, so I thought it was you. Okay, so okay, thank you for answering. Uh, yeah. So now what I'm going to do? Firstly, I will create an object only of the base class. Okay, I'm going to create an object only of the base class, and that time we know that whenever we create an object, the constructor is called automatically. So this one. Okay, and when I'm creating the object, I'm not passing any parameters here. Since I'm not passing any parameters here at the time of creating the object B, so the non-parameterized or the normal default constructor gets called. That is this one. But suppose I pass two values here, like 2 and 3, then we know that the corresponding header will be checked of the constructor. This is the matching one. So this will get called, and it will print the value of x and y. So x is equal to 2 since I have passed 2, and I've passed 3 also, so y is equal to 3. So 2 and 3 will get printed. But in this case, suppose I don't pass any values, then we know that the this one will get called. I am a constructor. So I'll run this and show you. So I am a constructor will get printed. Okay. Now, if I create an object of the derived class and I'm not passing any parameter, so I know that this constructor of derived class will get called. Okay. For now, just ignore this super something I've written here. Just ignore this part. You know that this derived constructor is going to get called, and it will print I am a derived class constructor. Okay. Now, I've also told you that first of all, we know that two constructors will be called. One is from the base and one is from the derived. But which one from the base, which constructor of the base class, that we have to see now. Okay, so when we are calling the derived class, I'll first run this program to you so that you see how the output is. So as you can see, I'm only creating object of derived class, but I'm getting some two outputs. How is it? This constructor base one is getting called first, as I said, base class constructor first, and then the derived class constructor. Okay, so always remember that when you're not passing any parameters, this derived one, this constructor gets called, and even to the base class constructor, you are not passing any parameters. Okay, even to the base class constructor, you're not passing parameters, so this constructor gets called. It will get clear when we see further examples. I'll show you that time. Okay, so when we are not passing any parameters to the base class, we know that this base class constructor gets called. Now suppose I want to pass some parameter to my base class. Okay, I want to, on my own, I want to do it. Then what I'll do, I will use one super function type. I'm seeing some different names coming up today requesting to join this meeting. Anyways, okay, so here what I'm going to do, I'm going to write super. Then within brackets, suppose I specify two values, 2 and 3. So now how it will work is, when you create derived class object D, you're passing two parameters. So this one will get called. And here you're writing super xy. This super keyword will help you to pass parameters from this derived class constructor to the base class. Now you know that using the super, I'm passing x and y. I'm passing two parameters. So in the base class also, the constructor which will be selected is with the one which has two parameters, not this one. This is non-parameterized. Since you're passing x and y, I mean 2 and 3, two parameters you're passing. So this base class constructor gets called from your derived class constructor. So you're calling base class constructor from your derived class constructor. But do you have to do this every time? No. Why? Because just now we saw the previous example. When I don't have super keyword, what happens? The just a minute. When I don't call with the super keyword, then the constructor of the base class, which is non-parameterized, was getting called. That is by default, it will get called. But if you are using super and you're passing some value, some parameter, then the corresponding definition of constructor of the base class gets called. Okay, so let me run this program and show you. So when you create derived class object without passing any parameters to the derived class, here I'm not passing any parameters to my derived class. That is why this derived class constructor will get called. And within this, I'm passing 2 and 3 to my base class constructor. So this base class constructor gets called. And then I will come back here to run this code. I am a derived class constructor. So from the super, you will jump over here, call the base class constructor, print this statement, then come back here and then print I am a derived class constructor. Okay, so let me run this program. So as you can see, I created the object without passing any parameters. So this one was called, 2 and 3 got passed over here and it printed 2, 3. And then I came back here and I'm printing I am a derived class constructor. Is this concept clear?
Yes, sir.
Okay. Yeah. Now what if I just write super with empty brackets? Okay. I'm not passing any parameter. So it is expected that this constructor of base class gets called. Let us check. Okay. And it is happening. Even if you don't give super keyword also, the same output you get. Even if you give super keyword, same output you get. But super, why we use? In case we want to pass parameters to our base class constructor. Means if we want a particular constructor to be called, parameterized constructor. Because depending on how many parameters we pass, accordingly the definition of the constructor will be selected from the base class. If we pass two parameters, this one will get called. Suppose we pass three parameters and you have that option also here like base 1, and then you have int a, int b, int c. Then and you have defined something here inside the bracket, something you've written. Then you're passing three parameters in your super. Then 1, 2, 3 will go here. A is equal to 1, b is equal to 2, c is equal to 3, and it will execute this constructor. So you can select which constructor you want to execute. That is my motive of saying this. Okay, and you can also do by passing parameters to your derived class 14 and 9. They will get passed to this constructor of the derived class. And this x and this y, those same xy I'm passing to my base class. Right, 14 and 9 will get stored in x and y, and that same xy I'm going to pass to my base class. That means here. And tell me one more thing, the xy that you're seeing here inside the base class for this constructor of base class, and the xy that you're seeing here for the derived class within the derived class, are those xy same or are they different? Are the variables same or only are the values same? Means this x and this x is same x, or are they two different x variables and just that their value is going to be same, or is it the same x variable? Means I want to say that this x and this y, their values you're going to pass. You're not going to pass the any address or anything. So x and y, that is 14 and 9, will get stored in this x and this y. But this x and this y variable is not the same. Okay, I'll explain it even more clear using the whiteboard. Just wait for it to load. Just a minute. Okay, so you have your derived class constructor over here, and in that you have got some variables x and y. And you have your base class constructor as well, in which there is again x and y. Okay, now you will define something inside this constructor. Now x and y are nothing but when I create my derived class object, when I write say derived obj equal to new derived. Okay, and then when I pass two values 14 and 9, okay, these values 14 and 9 will come over here. So 14 and 9 will come for this x, it will become 14, and this y, it will become 9. And this 14, 9 using my super, that means using super, and then I'm passing x comma y. So this x comma y, what is the value of this x and this y? Can you tell me now? See, what is the value of this x and y? I have passed 14 and 9 to x and y. So what is the value of x and y? Can you tell me?
14 and 9.
Yes, this is 14 and 9. Okay, this 14 and 9, I'm going to pass to this x and y. Okay, so this 14, 9 are going to go over here. So now this x will become 14 and this y will become 9. But this x that you can see here inside the base class and this y that you can see inside the base class and this x and y which is inside the derived class, those variable locations are different. Means for your derived class you have x and you have y over here, and for your base class also you have got x and y over here. Only thing what is same is their values, but the x and x, the place where they are stored in your memory, that is different. Though they hold 14 and 9, here also though it is 14 and 9, this x the memory location and this x the memory location is different. If you check the address of this x and this x, it will be different. So that is my thing that I want to say, that the variable storage where it stores in the memory, that is different. Only the value that it is storing is same. Now is it clear?
Yes, sir.
What about others?
Yes.
Okay.
Yes.
Okay. Okay. So instead of here x and y, you can also have a and b. No problem. It is just some variable name. But you should not get confused seeing the same variable name. That's why I told you all this. Okay. Note that the variable storage location inside your memory is different. Only the values that they are holding are same. They can hold any value, but they are different memory locations which have been given to x and y. Okay. Now, now I'm going to create first of all a child of the grandchild class. That means child of derived class. This class ka I'm creating an object without passing any parameter. So this particular constructor will get called, right? And here I am not using super keyword. So will the constructor of its parent will it get called or will it not get called?
It will get called.
Exactly, because just now we have seen that even if super keyword is not given, then by default the non-parameterized parent class constructor will get called. So which is the non-parameterized parent class constructor? This one. This is the parent for the grandchild. I mean, for the this class child of derived, the derived one class is the parent. Okay, so um, this constructor gets called. Now inside this constructor, I'm using super keyword 1 comma 3. So it will call its own parent constructor. Now its parent is what? Base one. So which constructor of base one will get called? The first one or the second one?
Second one.
Second one.
Second.
Yes. Okay. So it depends on what you're passing inside your super. If you pass one parameter and that option is there, then that will get called. If there are two parameters, that will get called. You can also have variable length arguments here. For example, int dot 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 arg. That means two parameters are compulsory. I mean, at least three, and then you can have more than that also. We know what are variable arguments. Minimum three parameters are needed. Okay, so that also is possible. Whatever is a normal function, whatever you can do that with constructors also. But from functions you can return values, from constructors you cannot return values. So some differences are there, but variable length arguments, all such concepts are same. Okay, so child of derived. Now I'm going to create an object where child of derived class, this one, I'm going to pass three parameters. That means consider grandchild. To the grandchild, three parameters means this particular one will get called. Now, here I'm passing xy. So this x, this y, and this x, this y is the same. It is within the same constructor. It is same xy. Now, not compulsory you always want to pass xy only. You may pass xy also. That is also possible. You can pass a value also directly. Or maybe you can pass some variable. I mean the variable's value. So in this case, I'm passing xy. You can also pass x and z. Not necessary xz, you can also pass zx also. Okay, it is not compulsory which order you're passing. You can pass in any order depending on your requirement. So here I'm passing xy, suppose. Now we know that this constructor will get called. Now here again I'm passing xy. So now this constructor will get called. Okay, and how you know where you have to stop? because this base one is an independent class. It has not been derived from someone else. So here you have to stop. You will not call any other constructor further. So when you call the grandchild class, its grandparent will get called first or its parent will get called first. Let us check that. Okay. Means when you're calling grandchild constructor, we know that its ancestors will get called first, right? So that is what I'll show you now. So I am an overloaded constructor. Yeah, this one and this one. Yeah. So how it is getting called is, we know that first of all, the most senior person that will get called first. Okay. Means who is the most senior? The base class, the grandparent. So then it is printing that I am an overloaded constructor X, I am an overloaded constructor Y. So these two statements are of the base class, grandparent class. Then the next senior, that is your parent, that is getting printed. And then finally, its own class is getting printed. That is this one. Okay, so this is getting displayed. Okay, so you know that whenever you're going to create like this, you're going to derive one from another, then from another and all. Then whoever is the first independent, the senior most, then the next one, then the next, and so on. In that order, the constructors get called. Okay, so first of all, this one, and then its own. Is this concept clear for everyone?
Yes, sir.
Yes.
Okay. So this is the concept of constructors in case of inheritance. So who will help you here? Your super keyword. Now, another case is when you have a class over here, then you have second class, and you have one class. Okay, so there are again three classes here in which some methods have been defined. So always trace the program starting from the main function, otherwise you won't understand which one is getting called and all that, because your execution always starts from main. So first of all, create the object of one class. So when you create one class, it is a base class, independent, it is not derived from anyone else. So it has methods like getA, which will display the value of a variable, and it also has a constructor which will initialize the a variable. Initialize the a variable means what? It will store some value in the a variable. Now when I'm creating my object of the one class, that time I'm not passing any parameter. So the non-parameterized constructor of one class will get called. One class means this is the name of the class. So we can see that there are two constructors here, but this is the non-parameterized one. And I'm going to print the value of a. But as you know, till now a has not been defined. Okay, it has not been defined. So will it give you error, or you will get some random value, or you'll get the value 0, or can you just guess, or if you know it, you can tell me. When a has not been initialized, if I try to print a, where a is a field or a state or a data member of the one class, it is a data member. That time, what will be the value of a if I try to print it directly without storing any value in a? Any guesses? Okay, so I'll just run this program and show you. It should print 0. Okay, as you can see. So remember, if it is a normal variable, like inside your main, if you have written int a and you have not initialized a and you're using println a, then that time A is a normal variable, it is not a class data member. In such cases, it will give you errors. But if A is a data member, that is, it is a variable defined inside your class, in such cases, if it is not defined by you, then the value 0 gets displayed when you print it. So if you remember in our PPTs, there was one section in which I had told you that we'll skip that part for now and we'll see the remaining. That is this part. So this was where I was talking about reference variables. So if it is a local variable, you do not have any default value. But if it is a class variable, or you can say if it is a reference variable, then that time, if it is an integer a, int a, which is not defined, then by default it will take the value 0. If it is float, by default 0, 0.0. If double, then 0, 0.0. If it is character, this is the particular encoding that we use, that it will be. If it is a Boolean data type, which is of the class, which has not been assigned as true or false, that time by default it will be false if you print that variable. So now you understood, if it is a local variable, normal variable in your main function, int a, you have not defined, you're printing, you'll get error. But if it is a class data member, you're printing without initializing it, you will get its default value. Is this concept clear?
Yes.
Okay. Yeah. And now, if I want to initialize it, I don't want it to be 0. I want some specific value. That time, I will have to call, I will have to, first of all, while creating, I'll have to pass some value. For example, if I pass 7, then it knows that the constructor should be having one parameter. So in that case, the constructor that we have available is this one, which has a single parameter written here. And since this is also a in the function definition and the class data member is also a, we'll use the this keyword. On the left hand side, always we'll use this. Okay, so that time 7 will get stored in the data member. And now if you call get a function to print the value of a, that time it will print 0 or 7. Can you tell me?
See 0
No, it will print 7. Just now we have passed the value 7, right?
for get a function.
Yeah, but while creating the object, I have passed 7 over here. Where is it gone? Here. I'm passing 7 over here while creating. So this 7, this is a constructor, right? So it will select the constructor which has one parameter in its header. That means this is the constructor which has one parameter in its header. So that 7 is getting stored in this A, and that 7 I'm going to store in the data member A. So now if I call my get A function, now what will be the value of A? 0 or 7?
7.
Yeah, 7. Okay. At the time of creating the object itself, you're going to pass this 7. So it doesn't matter you call get A, when you call get A, because at the time of creation itself, 7 has gone inside A. You cannot tell that now it is 0. 0 is gone. Now 7 is stored inside A. Okay. Similarly, you have a float B, which is already defined or initialized to 100.5. Now this 100.5 is the value, which is a non-zero value. Okay, that means you have already specified its value. If you are not specified, its default value would be 0.0f, but now it is 100.5. Now, when I'm calling my one class constructor and I pass a value like 7.7f, and that time I do not have a matching constructor call for that. Okay, so that time you can make this float if you want, just for explanation. And this also I'll make it a. Okay, I'm just making some changes. Okay, so that time you can initialize float. That means what? Here you have said float is 100.5, but you're going to pass some value at the time of creation 7.7. That 7.7 will get stored inside this A, and that 7.7 I'll assign in this float A. And then if I want to call get A for float, then when I return A, the value which I have passed that I'll get, or this value 100.5, which one I'll get? Can you tell me? Yes? Should I repeat?
Yes, sir.
Okay, so I'm saying that, okay, I just made some changes. Don't think what I did and all that, but see what I'm doing. I'm passing 7.7f. So the constructor which has a parameter, and that parameter should be a float, right? I'm passing 7.7f. So the parameter here, data type should be float. Do you agree with me?
Yes.
Yes. So that 7.7 is getting stored in A, and that 7.7 I'm storing in my data member A, and this is that A. So I'm going to update the value of A. So its original value 100.5, or will it be the updated value that I'll get now?
Updated.
Yes, updated value. Okay. So you can change the value also. It is not that it will be same. And I also need to call my get function, this one. So you're getting 7.7, not 100.5. Okay. So whichever you have initialized, no problem. You can update its value. So in the memory, 100.5 that will go, and 7.7 will get replaced. Similarly, you can have another class called a second class. Now in the second class, it has been derived from one class. You have float B, and in this second class constructor, you're first of all going to call its parent constructor by using the super. And you'll pass a single parameter, which is an integer. So I'll just make some changes here. Okay, so now what we are going to call our second class. We are going to create an object of the second class, and I'm going to pass an integer 5 to its constructor. So now a single parameter I'm passing. So inside this class, this is the constructor that will get selected. This 5 will get stored inside C. Now this 5, which is inside C variable, I'm going to pass to my parent constructor. My parent is one class. I'm passing a single parameter, so this will get selected. And C value is 5. That value 5 will get stored in A. That A value, which is 5, I'm going to store in A data member. So now int A of the one class is equal to 5. So here A is equal to 5. And now I'll come back here, and then I will print from my derived class. Okay, this super, due to this super, I had gone on top, I did something. Now I came back here, and now I'm printing from my derived class constructor. Okay, so now if you, okay, now in this get A function, I'm going to return A. But to access this get A, I can use my derived class. Can I use my derived class? My second class has been derived from one class. So using my second class, which is the child of this one class, can I access this get A function?
Yes.
Yes, I can access. Okay. So the A value should be what here?
Right.
Just now we saw A has been, what is the value of A? They have
5.
written it also here.
Fine.
It is 5. It is 5. Okay. So when we return A,
We
the
have
yeah, yes, you are saying something. Your voice is breaking. Okay. So you'll try to get the value 5. Now this get A function I can call using my object D, because D is my derived class object. Okay, using the derived class object, I'm going to access a method of my parent class. So now the value of A should be 5. Okay, as you can see. Now, there is a common method in both the functions. Okay, there is what is written here inside my base class, that is one class. I have a method called as common method. And in my derived class also, I have a method called as common method. So when I create an object of my base class, okay, here my question clearly. I have the same method in my base also and in my derived also. Using my derived class object, if I call the common method, then the method which is in the derived will get executed, or the method which is in the base will get executed. Can you tell me?
The one in the derived class.
Yes, very good. Okay, the one in the derived. We have studied this. What is this concept called as?
method
Last time.
overloading.
Yes, very good. Okay, thank you. So, um, yeah. Now, but if I create an object of my base class, first of all, I will not be able to access the common method from its derived. I can access the common method only from its own base class. I mean, if I use base class object, suppose B, then using B, I can only call the common method which I have defined inside the base class. I cannot access the common method which I have defined inside its derived class. So there's no confusion at all if you're creating an object of the base class. Okay, so I'll run this also and show you. So I have created an object of my derived class, and using this, I'll call the common method. The common method should print that I am from second class. So I'll say how can I call this common method? How should I write it? How to call it using the D object? Can you tell me? What should I write? D dot something. What should I write? I want to call common
Common
method.
method.
Common method. Okay. Remember this, how to call a method. So it should print I am from second class. And also its constructor will get executed. Okay, so method overriding, I have proved that always derived will get called. There is a way to call the parent also. The parent's common method can also be called. Let us see how. Now in my common method of the derived class, inside my common method of the derived class, from there I can call my base class, a common method. So what I'll write inside my common method of the derived classes. Now if you now remember that there is something common, that whenever from the derived class, if there is same name, okay, in the base class also something is same, and in the derived class also something is same, then always the derived class ka entity will get called. But if you want to call it from the base class, then always the keyword helps you. So here also super dot common method I will write here. So what will happen? First of all, when you call common method using the object of the derived class, that is D in our case, D dot common method, when I write this, first of all, it will execute the body of the derived class common method. and it will print I am from second class. Now I am saying super dot common method. That means the common method from the base class, that is one class. So now in the one class, you have this as your common method. So this will get called I am from one class. And then I will come back over here and done. Is this clear? How I'm calling the common method of its parent by using this? Is it clear?
Yes.
Yes, sir.
Okay, now I'll run this also. And their constructors also get called. Okay, so I am from um second class. And then I'm calling the base class ka common method. Okay. And yeah, okay, so you can call the method from the top also. Now, similarly, give me 1 minute. Okay, similarly, from as you call a method, how do you call a method of the base class from the derived class super dot common method brackets, right? We saw that just now, like this. Similarly, if you want to call the data member A from the base class, then you can access it directly also A. But suppose A is inside your base derived class. Here also you have int A inside your second class, which is a child, and inside your parent also you have the A. Then we know that if there is something common, always from the derived class the entity gets called. So the A of the base class will not get called. The A variable of the derived class, that is second class, that will get printed. So in order to print the value of A, which is of the base class, that time you have to use super keyword again. How? Super dot the name of the variable. Where have I written? Okay, here you can simply print super dot A. Now, if I have, okay, now answer this one more question. I have a parent class in which I have a variable A. Again, in my parent class, I have a variable B. In my child class, I have a variable C, and in my child class, I have a variable B. Now, from my child class, if I want to print the value of A, if I want to print the value of A, which is a member of the parent class, from my child class, I want to access a variable from the parent class. Then, is it compulsory to use super keyword over here inside my child? I want
No,
to call A. Okay, correct. Okay, no. Why? Can you tell me?
because A is not there in child class.
Exactly. Okay, very correct answer. Because there is, you can also say it like there is no naming conflicts. Okay, usually they call it as naming conflicts because there may be some conflict if there is same name. So naming conflict. And suppose from my child class, I want to call the variable B of my parent. Then do I need super keyword or is it okay without super keyword?
We need super keyword.
Yes, because again, in this case, there is naming conflict. Okay. But if I want to call B of the child class only, from the child class only, then do I need super or is it without the super?
No, we do not need.
Yes, okay, very good. So you have understood all the cases. Okay, very good. So others also agree, right, with what Pratik was saying?
Yes, sir.
Yes, okay. So it has many applications like this. Like maybe sometimes you want to call from the parent or sometimes you want to call for the child. And usually in programs, what happens, we give the names which are meaningful. Like if we are giving a signal, to someone, then we call the variable as suppose signal. So in the child class also we are giving a signal to the parent, also we are giving a signal. Then we call it signal. Okay, and we always want the signal of the child. That time it's okay. Or we can call it directly. But if we want the signal of the parent, then we have to use super. So in such cases, you can use super keyword to access the parent when it is not possible. Then another concept. Till now, if you have any doubts, you can ask me. Meanwhile, I'm making some changes here. Any doubts?
No, sir.
Okay. So here in this example of method overriding, I have a class A parent and B is the child, which extends A. Okay, means B is derived from A. So I'm creating base class object and I'm calling a method called as meth2 from A. This one from A, which is the derived class. Okay, sorry, A is the base class. A is the base class. So I'm calling meth2 of the base class, which will print this. So I'll first run this program. I am method 2 of class A. Okay, this is getting called. Now I'll create an object of the derived class, and again I'm calling meth2 only, where meth2 is in derived also and meth2 is in base also. And I'm running this. And it will call of the base class. Okay, and sometimes we also write this like this. This is annotation type override. Okay, because sometimes we may not want to override. In that case, we use a final keyword, and sometimes when we want it to override, we use this annotation. Like it is just like indication to the programmer. Like if I remove this annotation at override, and if I run the same program, you're getting same output. Okay, so it doesn't make much of a difference. You can give this, it's a good habit actually to give this override. Because why override? Because this meth2 of the B class is going to override the meth2 of the A class. Okay, then rest everything is like a normal inheritance. So this was about overriding. So today we have seen constructors in inheritance. We have seen the super keyword. Super can be used to call the constructor of the base class, particular constructor of the base class. It can also be used to call a method of the base class in case of naming conflict. Also the variable of the name class in case of naming conflicts. Okay, so we'll stop here for today. Any doubts you can ask me now. And you can put your attendance in the chat box. And okay, so just a minute. And complete your assignment also based on arrays and strings. I think so I've uploaded. Just check that.